So to me, we are now getting into the most important part of this section. Like I said, there's a quantum number, and this is on that table. N equals 1, N equals 2, N equals 3, N equals 4. So that is the principal quantum number, which means it's the first quantum number. It tells you the size and energy of the atomic orbitals. So N equals 1. If we just looked at calcium, 2, 8, 8, 1. 2 electrons in the first level. There are 8 electrons here, so let's do 4 and 4. There are 8 here. And
2 on the last.
did I skip something?
There's 2 on
Oh,
the last.
2 on the last one, sorry. And there's 1 here and 1 here. And I'm just filling that in. But what that shows is in N equals 1, this is the first sublevel. That's where the first 2 electrons go. Here's my second sublevel. It's a little bit further away from the nucleus. Here's my third sublevel. Here's my fourth sublevel. The principal quantum number tells me how many sublevels that I have and basically the energy or amount of energy that I have. So here it's called I still call these the so here's energy level 1, energy level 2, energy level 3, energy level 4. And these energy sublevels then are inside. So if I have a principal number of 1, so this first energy level has 1 sublevel. My second energy level has 2 sublevels. My third has 3, my fourth has 4. I could have 5, 5 would have 5 sublevels. So whatever my principal quantum number is, it tells me how many energy levels I have, which will also tell me how many is in each. So, and like I said, the lab that we do will help explain that much, much better. And I'll go, fireworks totally work off of that same conception. Here, I do highly suggest that you look at these. So these are orbitals. There are s orbitals, there are p orbitals, and there are d orbitals. An s orbital is going to be shaped like a sphere. They're spherical, and their size increases the larger the quantum number is. So this might be a quantum number of 1, and this is a quantum number of 2. Then there are 3 p orbitals. If I have a p orbital, it is dumbbell shaped. So it has 2 parts to it. 1 electron will go here and 1 electron will go there. So S spherical, P dumbbell, and then if I have a D orbital, it's kind of like a clover leaf. It's going to have 4 parts to it. And then I have a special one for my fifth D orbital. So spherical, dumbbell shaped, and what I would call clover leaf with the plane that goes with it. So the shapes I kind of expect you to know the shape of an S, a P, and a D. And this table, by the end of the chapter, you need to understand this whole table. If my number is 1, I have 1 sublevel. That sublevel is an S. It's going to have 1 orbitals, and it's going to have 1 total orbital. If I have a quantum number 2, it's going to have 2 sublevels. so they go in order, an S and a P. 1 orbital in an S. There's 3 orbitals in a P, which gives me a total of 4. If I have an energy level of, or a quantum number of 3, I'll have 3 energy levels. An S, still 1. P can have 3. D can have 5. Total of 9. And last one that we'll use, 4 SPDF. There is also 5 SPDFG, but we won't get that big. 1, 3, 5, 7. Total those up, I get 16. So right now, other than memorizing this table, I don't expect the numbers to mean much to you. After we do the lab, I expect that you know what those numbers mean. And the last is just your review page.